Hi guys, welcome back to Techie. Today we are going to see about cross-site scripting, which is most common web vulnerability. So, what does cross-site scripting mean? So, attacker tricks the website to execute his JavaScript. What does it mean? The most front ends consist of input fields, right? So, attacker injects his JS script into that input field so that the script will be executed to session cookies. So what is the advantage of steal the session cookies is, so by using this cookie, the attacker need not have need not have login credentials. He need not have login credentials. Even the login page with MFA, once the login is done, the session cookie is generated and stored on the browser, right? Stored on browser. That that cookie will be stealed by attacker so that he can perform actions of user, actions of users, actions of user. For example, what does mean actions of user in main here? Uh, like it is a bank website. Let's assume it is a bank website. Once he got the access to his login, he can transfer the funds, or he can view the balance, and assume it is any website also, he can have his data of that user. So that is one of the use case, that is one of the attacker main goal here. And any sensitive data can be stolen by the user, by the attacker. And one like there is a use case when the attacker suppose some script is injected by the attacker. He will redirect, he will redirect, he will redirect to the page, he will redirect to the page, phishing page, uh, then phishing page where it will tell session timed out, enter credentials, which will look like same web page, web page, phishing page, so that the user unknowingly enters his credentials. So attacker again gains the control of his credentials. This is also one of the use case of the main goal of motive of attacker. And there may be key logging, whatever user enters, that keystrokes will be stayed by the attacker. Um, and you can read the like generally browser store passwords, right? General browser stores passwords. So that passwords can be leaked by this kind of XSS attacks, cross-site scripting. So to this video, to know about what are types of XSS, and we will see one of the XSS attack also with the demo, and how to mitigate this XSS. Yes, you got clear idea, right? So there are mainly some of the five types of XSS: reflected XSS, stored XSS, DOM-based XSS, self XSS, blind XSS. So in this video, we will be seeing about reflected XSS. So what does this reflected XSS is? Attacker Attacker inputs some of the JavaScript code to the input field. It will be passed to the server, that input. The server, without checking any sanitization, it will return to the front end to render that. So the response will be immediately seen by either by attacker or the user. Like what I mean is, whenever the if the JavaScript code is like such a way that to send a cookie to the attacker server, then the response will be seen by the attacker there. Or assume there is a he injected a JavaScript code to redirect to the some of the phishing page like the session timeout. Then the response immediately is seen by the user. So that is known as reflected XSS. So let's quickly dive into the demo without wasting much time here. So this is the Flask code. I'll just quickly go through the what all things are there in this Flask's page. Uh, so there is a home page which will render home render template home.html. Just it will show the who is the user logged in and balance in that page. You can see here. See, this is the template for the home. Welcome user. See that what is the balance available. And there is a form input search. Type something to search. So what does this search do this? Just search simply whatever request comes that search page. In that search page, we are simply showing this is the you search for this one. For this purpose of demo, that I am not taking any real use case, but just you search for this one like that. So now, login endpoint also is there. Like if he already user logged in that session, then they redirect to that home page. Otherwise, it validates. It gets the username password field, and it validates. Then it creates a session for that user, username and balance. So this session cookie, which is will be signed by signed by this secret key. It is kind of encrypted. You can mean the by directly seeing that cookie, we cannot directly get the username and balance from that cookie. Okay, and then it is redirecting to the home page. Okay, and there is another route, logout route, which just clears out. Okay, so let's just simply go through this. Uh, this is the server I'm running here. Just let's log in here. Localhost, I'm just logging in. For this purpose of demo, I have not connected any database here. Just I kept a list of users, user logins, username, password is 123, balance is. So username, let's log in with this ABC user, ABC user, and password is 123. So once I logged in, welcome ABC 2000 is the balance. Okay. That's great. Okay. Now, suppose same URL I am running in incognito, but let's say incognito is the attacker and this is the normal user. Now, the motive of attacker is to know the balance of ABC. How we can know the balance of ABC? So here lies the main trick here. Uh, application, if you go, see, once it is logged in, you can see, wait, just a minute. You can see that session cookie here. This is the, and if we go into the attacker mode, And if I see there is a session, there is no session key. So if we try to see steal the session key, then attacker motive is achieved to log in here. Suppose, let's say, like a document, like just we to access that session key, just you press document dot cookie. Okay, this some CSRF token I got and some session key also I got. If it is stealed by the attacker, then this motive is actual. Suppose just I will just demonstrate by setting that session key, right? Uh, so he is logged in. This is the session key, right? I will just copy this and paste in here. Paste here. And this document cookie, I will what I will do in a incognito window, in attacker window, I'll paste it. No, this it is not allowing. So just type allow pasting document.cookie. I, so now attacker, let's see the attacker got the cookie here. No, he'll just reload that page. Oh, that's attacker motive is achieved here. He got access of EBC data. So intentionally, how to avoid this document dot cookie access here? Like this is the JavaScript code, right? How to avoid this document.cookie accessing? Intentionally, generally, frameworks disable that accessing using that cookies through JavaScript. Uh, like normal, some web servers may defaultly they may not disable it the cookie. So to enable it, just make it true. Session cookie, you just enable it. HTTP only. Means the session will be passed only through HTTP request is only. What I mean here is, uh, here, I'm reloading again here. The cookie is sent only in HTTP request headers only. It cannot be accessed by JavaScript code. Now, just again, document.cookie, you type it. Okay. Sorry. This flag is still not set HTTP only. Yeah, right? So just log out. Session is created with not without any flag HTTP only. Now you see the session is cleared out. Session cookie is not there. ABC again. While login. Now let's see the HTTP cookie is set by the browser because of that flag we enable. Now you execute that document.cookie. See, the session cookie here is not accessible by this JavaScript code. Okay, assume you forgot to this disable this HTTP only cookie. I'm logging out from the user session. Now, how the attacker will get the cookie. How he will steal in real time. I'll just explain that one also. Here is the attacker code. Attacker code app app dot one root steal. Whenever steal, he will get the argument C, and in the stealed code token, he will be visible in his browser. And then you have written show all the steal cookies in the one page also. This stolen cookies is stored in the list. Okay. So I am running that attacker session also on the port 9000. Okay. You got this right. Now just I will log in again. Now I'll log in again in the user session. ABC 123. Okay. I logged in successfully. Now what I will do here? Assume the attacker knows this search. So example, he tried script alert ABC slash script. Assume he have seen this search and whenever user not there, he have entered this script whether it is vulnerable. Oh, see this URL. It is just taking query and it is returning that whatever query is executed is able to run that. Now, in real time, ABC, like whatever is searched, it is coming, it is rendering here. So that script is executing here. So he somehow he know the vulnerability and he he know that whatever query he passed over here, then it is executing by the search page. So what this attacker he will do is instead of this, now attacker he will pass on query equal to this one, query equal to total this one. He will do either SMS, email, or some way, some phishing way, social engineering he will do to the user. So already the user already opened that page and that session is already present, right? So now I will open this page now. Let's see. Now that user clicked that page, then he opened this one. Let's see that from the attacker window. See, in the attacker window, he got the token. This is how it will be compromised. So to avoid this, we should not run the JavaScript code inline to that HTML. External JavaScript code, it can be there. Because of enabling inline JavaScript executing, this problem came. To avoid this, now assume, assume, see, now I will just again execute this one. Just I will execute this one. I will just execute this one. Search. Now attacker will get another cookie. Yeah. This is what the problem with this. So to avoid this, we need to use cross-site, this content, we should need to set content security policy. So just I will, after every request, I am setting the header content security policy. Script source, it should not, in content security policy, generally, what is the advantage of content security policy? We'll just quickly go through that content security policy advantage. So it will not run external scripts unless you specify in the content security which scripts are genuine and you need to allow that content security policy that scripts prevent loading of scripts from external sources. And no inline scripts will be executed, no JavaScript injections, no on click on error will be executed slash and anything events will be not executed and As you are not loading external scripts, you will be protected from supply chain attacks. This is the advantage of the. Assume I have set the content security policy now here. Now I'll just execute again that script again now. See, executing inline script violates the following content security policy. Either unsafe inline, you should use unsafe inline in the content security policy. If you use, then only it will be that script can be executed. Or you need to provide the hash of that script to run that particular. It is not changed. If you want to use the inline script, that hash you need to specify. It is required to enable the inline execution, so it is not executed. So attacker also here, if you can see, attacker also you will be not attacker also will not be able to receive that token. So this is the advantage of content security policy. Now, uh, assume you don't want to do at application side. This is also possible. So how it can be done? Just you need to add the header in IES. Just in HTTP response headers, you need to add HTTP response header. You remove this, not required. So I am adding content security policy here. Default is source. Okay. Default source self script source also self. Where it is. So now I've removed this after is the request to send the content security policy by the application itself. So I'll just reload that again, uh, whether it is executing or not. Script. So console. We didn't got this one. The attacker was able to. Okay. Sorry, I get. Why I'm getting here is I have run in the local port, but IS what IS is running here is 5010 port. So just you will I will run through IS localhost 5010. So we'll execute that script. So it's violated. Why? You can see content security policy is enabled here by IIS. So this is the advantage of content security policy. So this is the one of the way we seen HTTP setting HTTP only cookie. Then in that JavaScript access will be not able to access that cookie. Stealing cookies is disabled. CSP does the JavaScript code itself it will be not executed. Why I mean because assume I am again removing this response headers for us, no, it's not only purpose of only cookie stealing. The attacker purpose is not about cookie stealing. He may redirect to some other page. Assume in this script, assume this window dot delocation. You will redirect the page. You will redirect the page to this attacker page, which is a phishing site. So assume here I will just so it is redirected to some of the phishing site. Assume google.com is there. Just I'll just because for demonstration, I'm just showing that some of the page it is redirecting. See, it redirected to Google page. The, to avoid that execution, we need to enable that content security policy. Content security policy is important for any website. It should not be avoided. If developer forces to, it is required, then he should either use the external JavaScript, external means not inline JavaScript code. He should write another external JavaScript which can be referred in this HTML page. This is the purpose of this one. So I have enabled back again. Let's see whether it is redirecting back or not. It's not redirecting because content security policy is enabled. This is the purpose of content security policy. Hope you got a clear understanding of content security policy. And let's see other preventive measures also. We can sanitize the input. Assume you don't have content security policy here. Assume content security policy is not there, and we can sanitize. We can sanitize the input. We can sanitize the input means we can clean that script tag slash. It will be replaced by greater than sign. Assume just I'm opening again. Yes, searching again. Mm window.location search. So whatever it is, the input is sanitized by the server so that the script is not executed. If you say here, this is referred dash and ampersand greater than. So that's why that script is not executed and it is sanitized at server side. So that is one of the ways sanitizing inputs. Input validation is another way. And using HTTP only cookies we have seen already. And the content security policy also we have seen. And generally the frameworks to not to run the inline scripts for the inputs generally come with auto escaping generally. If I run this now, still it is all that auto escaped whatever execute whatever script is provided by the attacker, it will be not executed. So wantedly, the developer should not avoid it. Should not be treated as safe. Some of the developers I have seen, they write into in order to avoid some of the problems. They use this safe. It should not be done in real time production environments. So this is one of the way frameworks come up with these of the methods. So we hope you got the clear idea of this. XSS in reflected XSS preventive measures. We'll see other type of XSS attacks also like stored SSS and blind SSS, self XSS, DOM based XSS in further videos. Hope you like the content. Hit like and subscribe for more kind of these videos. Thank you guys. Thank you.